Today we're going to be looking at two different types of equations. The first equation that we're going to look at are linear equations. Linear equations contain one or two variables, and this really depends on what the slope is. When the slope is 0 or undefined, there is one variable. When our linear equation has any other slope, we're going to have two variables, an x and a y. The power of both x and y variables is always going to be to the first power, or to 1. When we plot the coordinate points, we create a straight line. And the format for all linear equations is going to be y equals mx plus b. When we break this down, y is our dependent variable. M is the slope, which is the change in y divided by the change in x. The slope changes the steepness of the line and or its direction, either up or down, depending on if it's positive or negative. X is our independent variable, and b is our y-intercept. Plus or minus is here because a y-intercept can either be positive plus b or negative minus b. Quadratic equations always contain two variables. The power of y is always to the first power. There is always the term ax squared, or ax to the second power. B times x to the first and plus or minus c may or may not be present. It really depends on the equation that you're given. But no matter what it looks like, plotting those coordinate points will always give you a U-shaped line. We also call this a parabola. The format for quadratic equations will look similar to the linear equations. Y equals ax squared plus or minus bx plus or minus c. In both types of equations, y is the dependent variable. A is the numerical coefficient of x squared. This is going to change how wide our parabola is and its direction, if it either opens up or opens down, depending on if A is positive or negative. B is another numerical coefficient. This is going to determine the point of symmetry, or the vertex. This is the point that it comes to. X is still the independent variable, and C is now our y-intercept. Now, there are unique features to the data tables that tell you what type of equation you're working with. For linear equations, the change in y is the same between any two consecutive points. Let's go ahead and take a look at that. In the following data table, our y values go from 7 to 10 to 13 to 16, which means it always increases by 3. Because that change is consecutive and it's always the same, this is going to be a linear equation. For quadratic equations, the initial y is different between any two consecutive points. The second change in y will be the same for any two consecutive coordinate points. Let's take a look at this one. So the first change in y is going to be different between any two consecutive points. So this is plus 1, plus 3, plus 5. That's our first change in y. We could say this is delta y1. And if we look at the second change in y, to go from 1 to 3, we add 2. To go to 3 to 5, we add 2. This tells us that we have a quadratic equation. Now, if it didn't do this, we would have a different type of equation, And we're not going to worry about that right at this moment. If we look at the features of their graphs, the linear equations are always a straight line. We've already mentioned that. They either point up or down. Up means that the y values are going to increase as we look from left to right on the x-axis. Down is going to mean that the y values decrease as we look from left to right along the x-axis. So this first example here, our y values are decreasing as we move from left to right. So this one is pointing downward. Our next example looks at one that points upwards, where the y increases as we move across the x-axis. Quadratic equations are parabolas. They have that U shape to them. They either open up or open down. They cannot open sideways. Up means that the y values decrease, then increase as we look from left to right. Down tells us that the y values increase, then decrease. This first example here shows y decreasing at first. So y is decreasing. We hit this point right here. This is our vertex or our point of symmetry. And now it is increasing again. So this is one that opens up. The next example shows one that opens downward. Y increases, 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 hits our vertex, and now starts to decrease again. For our first example, we're going to write an equation using the data table given to us. We need to identify whether it's linear or quadratic, and identify if it points or opens up or down. So here's what we're going to do. We're going to figure out our change in y first. To go from 10 to 6, we minus 4. To go from 6 to 2, we minus 4. 2 to negative 2, we minus 4. I know right away that this is a linear equation. And we see that x is going up by 1 each time. So we're going to look at our slope to figure out if this opens up or down. Our change in y over change in x. Change in y we said was negative 4 over 1. M is equal to negative 4. Remember, if m is negative, if the slope is negative, this is going to point downwards. Let's take a look at another example. This time we're going to write an equation using the graph. One of the things that I noticed right away is that this opens downward. So I know that a is going to be negative. Remember, this is ax plus or minus bx plus or minus c. Our vertex is here at 0, 0. So I know that this is going to be equal to 0, so I can ignore it. This width here is consistent. I'm going to assume that I don't need bx, but we'll just have to wait and see. I need to figure out what a is. So my first change in y is plus 3, and then it goes to plus 1. The change here is 2. I'm just thinking here because I'm looking at this. And I think this is just negative x squared. Now hear me out. It helps to verify that there's this change in y, but if I want to know what a equals, negative 1 squared is 1. So how do I get negative 1 as a result? I have to take negative x squared. So negative times negative 1 squared is going to be equal to y. This is negative 1, and that's exactly what y needs to be equal to. So this is going to be y is equal to negative x squared. And if I lost you, I apologize. We're going to look at another example. We're going to try to figure this out. For example 3, we're going to write another equation using the data table. Identify whether it's linear or quadratic, and identify if this opens up or down. My change in y is plus 4, then plus 6, and then plus 8. This is a change of plus 2, plus 2, which tells me that this is quadratic. We need to figure out if this is going to open up or down. Because we have a data table, we can draw a quick sketch. Negative 2, negative 9, negative 1, negative 5, 0, 1, and 1, 9, 1, 2, 3, 4, 5, 6. Now, if I were to draw this, it would make the most sense that I have a mirror somewhere around here, and that this would open up. It's much easier to write an equation looking at a linear equation from the graph. We are going to pick this red point here. This is negative 5, negative 2. And this point up here, which is 5, 5. To calculate the slope, we look at the change in y over the change in x. This is y2 minus y1 all over x2 minus x1. This point over here is x1, y1. It's the first point we start at. As we move our way over, we now have x2, y2. This is going to be 5 minus negative 2 all over 5 minus negative 5. Anytime we have a negative minus negative becomes positive. 5 plus 2. 5 minus 5 is 5 plus 5. This is 7 over 10. So y equals 7/10 x plus our y-intercept is right here, right in the middle. This is 1.5. Or you could say if this is 3/2. Or there's still one more way we could write this. 7/10 x plus 1.5. Any of those three would be acceptable for me.